Let's talk about density. We'll talk about it, you and me. We'll talk about mass and volume and what the ratio may be. Density. You should, again, probably know most of this from middle school, but density is an intensive physical property that relates the ratio of mass to volume for a given object. Remember that an intensive property, this is a word we learned in a previous video. An intensive property means that the density of a substance is always the same no matter how much of the substance you have. If I have a drop of water, if I have a lake full of water, or if I have a cup of water, it's all got the same density. The units for density are typically in grams per cubic centimeter for solids, or grams per milliliter for liquids. That slash there, please don't say slash when you say this out loud. Don't say G/cm, don't say G/ml. It will make me cry, even though I'll never hear you say it. That's a per. That slash means divided by or per. So that's grams per cubic centimeter, that's grams per milliliter, okay? Density can be used to help identify a substance, since it is an intensive property, meaning because it's always the same all the time, I can check a substance's identity because if I measure its density, then I know like, well, if this thing's density is 20, it can't be iron because the density of iron is blah, blah, blah. You know, like you can use it to narrow down the identity of a substance. An object will float if its density is less than the density of the fluid that it is placed in. The density of water is 1 gram per milliliter. So objects with a density less than 1 gram per milliliter will float in water. Ta-da! Let's think about those states of matter. We know that gases are going to be not very dense because the whole definition of a gas is that all those particles are really far apart from each other. So they're going to take up a lot of space, but they're not going to weigh very much. And that means that ratio is going to be a really small number. Look how small these numbers are. Okay, gases have a really low density because what's happening is that they have low mass in a large volume because they're so spread out. Liquids, like would be these two, kind of getting denser and denser. They're getting closer together. You have a little more mass in each amount of space. And so that's going to make the density higher. And for these liquids, we can see like, yeah, these are all way more dense than the gases. Like there's a definite liquids are greater than gases situation going on for density. And then we can talk about the density of solids, where the density is much higher because you have more mass in less volume, and that means the ratio is going to end up being a bigger number. And again, we can see that for most of these solids, they are more dense than most of these liquids. It's a little fuzzier because basically you can tell like all of them are way bigger than gases, but liquids and solids are a little more dependent. Like mercury is just an intensely dense liquid anyway, so it's way denser than even some of these solids. But in general, solids are more dense than liquids. Everything's more dense than a gas. If we think about our formula for density, mass divided by volume, that should make this whole high density, low density situation make a little more sense. If you think about like a big number on top, a big mass, with a little number on bottom, a small volume, that's going to give you a big number when you're done, right? Which is what happens with really dense stuff. If you have a lot of mass and a little bit of space, you're going to get a big number. Whereas like this is just the way fractions work, right? If you have a little number on top and a big number on bottom, right? Like 1/20, that's going to be a little number. And that's how you get these like tiny densities for gases versus like a large density solid or liquid would be like 20/1. That's how ratios work. Yay. Middle school math. Okay. A high density, again, means that you have a large mass in a small volume. And a low density means that you have a small mass in a large volume. It weighs very little, but it takes up a bunch of space. That's not very dense. There are some practice problems here. I'm going to do a couple of them with you. This is now math, but you can do the math on your Chromebook. You could also just like use the calculator on your phone, right? Like, can you see that? Is it too bright? There we go. Yeah, like eventually we're going to get to more complicated math and I'll show you some like better tools to do that with. But right now we're really just multiplying and dividing. So like just use your Chromebook calculator, use the Google calculator, use your phone calculator, like whatever. For density, the math itself is simple enough that you can use whatever calculator you're comfortable with. Later, I'll show you other tools when we do more complicated math. By the way, we're going to do so much math in this class. Get ready. Okay. Number one, what is the density of a block of marble that occupies 287 cubic centimeters and has a mass of 869 grams? Well, it helps to like label your stuff, right? So density is what they use a question word right here. What is the density? So that's the one we don't know. They tell us that this number right here is a mass. So that's going to be your M for mass, which means that 287 cubic centimeters, that's going to be a volume, which by the way, you should know from like middle school that cubic centimeters measure volume anyway. Any unit with a power of 3 is going to be a volume. So we'll recall density is mass divided by volume. So if I'm looking for that density, I need to take that mass and divide by the volume. And again, you can stick that in your phone calculator if you wanna. And you get 3.027. I'll just round that to 303. Like the band. And your units are going to be grams per cubic centimeter. I know those are my units because if I look, that's actually what the units are written as in my math even. Grams over, grams divided by grams per cubic centimeter. It's right there on your paper. So, yeah, I mean, that's it. And we also know from our notes, right, that grams per cubic centimeter is one of the density units. We talked about that. Whoops. So now we'll try another problem. I actually want to look at number 5 together. JK, number 6. A student has 1,500 milliliters of water. What is the mass of the water in grams? And it says, hint, the density of water is in your notes. So let's think about it. First of all, 1,500 milliliters, that's a volume. They're asking, here's my question word, what is the mass? So mass is the thing we're looking for. And I know density equals mass divided by volume. We can like rearrange this equation, right? And this is algebra 1, multiply by volume on both sides. And then you have that this cancels out. Mass equals volume times density, right? So really we just need to multiply the volume times the density. Well, they tell us in the problem that the volume is 1,500 milliliters. And it says the density is in your notes. So let's go back and look in your notes. Oh, density of water is 1. That means I'm actually just multiplying times 1 gram per milliliter. So 1,500 times 1 is going to be 1,500. And then we're left with grams for our unit of mass. because this is maybe getting a little ahead of ourselves, but we're looking at milliliters times grams over milliliter. And like, that means you get grams times milliliter divided by milliliter, and milliliter divided by milliliter is just 1. So grams times 1 divided by 1 is just grams. Don't worry about it too much. We'll get there. But yeah, we're left with grams for mass. That's the bottom line. Honestly, the rest of these questions, I would prefer you to try by yourself and then check your work. I'll be sure there's a key put up somewhere. Again, I'm recording this in July, so like, I don't know, but Schoology or Google Classroom or something will tell you where to find the answer key to this. And if I forget to tell you, because I recorded this video like probably a month and a half before you watched it, just like tell me, hey, where's the key for that? And I'll be like, oh yeah, sorry. That's fine. Try the rest of this page yourself, this guided practice, and enjoy your density problems.